You're in a design meeting, and the team is discussing the structural scheme. The architect wants wide, column-free spaces for an open office layout. The project manager is concerned about the construction timeline and cost. And you, as the engineer, need to ensure it's all structurally sound and efficient. The solution to balancing all these demands often lies in one critical decision: choosing the right type of slab. The slab isn't just a floor you walk on. It's a primary structural element that consumes a massive portion of your concrete and steel. Picking the wrong one can lead to bloated costs, construction delays, and functional limitations. In this video, we're going to demystify the world of concrete slabs. I'll walk you through the most common types, from the basic conventional slabs to sophisticated post-tension systems, explaining not just what they are, but why and when you would use them. This knowledge is fundamental for anyone involved in the design and construction of modern buildings. Let's start with the most fundamental classification: how the load is carried. This leads us to the one-way slab and the two-way slab. A one-way slab is supported on two opposite sides only by beams or walls. The key characteristic is that the ratio of the longer span to the shorter span is greater than 2. In this case, the slab primarily bends in one direction, transferring the load to the two supporting beams. You can visualize it like a set of planks bridging a gap. The strength runs in one direction. Reinforcement in a one-way slab is primarily provided in the shorter span direction. These are common in verandas or in buildings with a very rectangular bay layout. Now, a two-way slab is supported by beams on all four sides, and the ratio of longer span to shorter span is less than or equal to 2. Here, the load is transferred to all four supporting beams, meaning the slab bends in two directions. This is a much more efficient way to carry load, allowing for longer spans or thinner slabs compared to a one-way system. The reinforcement is provided in both directions, with a mesh of bars at the bottom to resist the sagging moments. A pro tip for site engineers: always check the placement of the reinforcement. In a two-way slab, the bars in the shorter direction are placed above the bars in the longer direction at the intersections, as the shorter span carries a slightly greater moment. Now, let's talk about a system that architects love for its clean aesthetics: a flat plate. This is the simplest form of a two-way system. It's a concrete slab of uniform thickness supported directly by columns, without any beams. This gives you a completely flat soffit, which minimizes the floor-to-floor height, simplifies formwork, and allows for flexible partition walls. It's fast and economical to construct. However, there are significant drawbacks. Flat plates have poor resistance to lateral loads like wind or earthquakes. They have relatively low shear capacity around the columns, which can lead to punching shear failure, and they can experience excessive deflection in longer spans. To mitigate punching shear, we often use drop panels thicken portions of the slab around the column and column capitals flared column heads. When you add these elements to a flat plate, it becomes a flat slab. The drop panel significantly increases the shear strength and stiffness at the column connection, allowing for greater loads and longer spans. These systems are the go-to choice for residential buildings, hotels, and parking garages where a clean ceiling is desired. When you need to span even greater distances without columns, or you need to support very heavy loads, you step up to more advanced systems. The waffle slab is a magnificent solution. It's a two-way concrete slab reinforced by a grid of ribs in two directions, with a thin topping slab on top. The void spaces between the ribs are created using modular fiberglass or plastic forms called domes. This system creates an incredibly stiff and strong floor that is also relatively lightweight. Because it's a two-way system, it efficiently distributes loads in both directions, making it ideal for large, column-free areas like auditoriums, museums, and industrial floors. The pattern soffit is also considered an architectural feature in many modern buildings. However, the formwork is more complex and expensive, and the overall depth of the floor system is greater, which can increase the building's overall height. A similar but different system is the ribbed slab, which is typically a one-way system. Here, the ribs are all oriented in one direction, supported by deeper beams. It's lighter than a solid slab, but not as efficient as the two-way waffle system for large square bays. For speed and efficiency, especially in multi-story buildings, prefabricated elements are king. This is where the hollow core slab shines. These are pre-stressed, precast concrete slabs with continuous voids running through them. They are manufactured off-site in a factory, transported to the site, and lifted into place. The advantages are huge. incredible speed of construction, excellent quality control, and immediate working platform as they don't require shoring. The voids reduce the self-weight significantly and also provide a convenient conduit for electrical and plumbing services. The main disadvantages are the need for careful coordination of connections and the reliance on cranes. They are perfect for hotels, apartments, and parking structures where repetitive bay sizes are used. Another innovative system is the bubble deck slab, which follows a similar principle of reducing dead weight. It's a two-way flat slab that uses large, recycled plastic spheres to create voids within the slab, replacing concrete that doesn't contribute to strength in the middle of the slab's depth. This can reduce the slab's self-weight by up to 35%, which in turn reduces the size of columns, foundations, and vertical reinforcement, leading to a more economical structure overall. Finally, we have to discuss the powerhouse of long-span construction, the post-tension slab. Post-tensioning involves placing high-strength steel tendons in plastic ducts within the slab before pouring concrete. After the concrete is cured, these tendons are tensioned using hydraulic jacks and anchored against the concrete, putting the entire slab into a state of compression. This compression counteracts the tensile stresses caused by loading, which effectively makes the concrete stronger and crack-free. The benefits are monumental: significantly reduced deflection, thinner slabs, and much longer spans. Post-tensioning can be applied to flat plates, flat slabs, and band beams. It's the preferred method for large office buildings, condominiums, and structures on problematic soils where controlling deflection and cracking is paramount. A crucial pro tip for any project involving post-tensioning: the anchoring and stressing operations are highly specialized tasks that must be performed by certified technicians. Furthermore, any subsequent drilling or cutting into a post-tension slab is extremely dangerous and requires a detailed as-built drawing to locate the tendons. In conclusion, the choice of a slab system is a complex trade-off between architectural desire, structural efficiency, construction speed, and overall cost. There is no single best slab. A flat plate might be perfect for a low-rise apartment, but a disaster for a long-span hospital with heavy vibration requirements. A waffle slab might be an architectural marvel for a museum, but overkill and expensive for a warehouse. Your role as a designer or builder is to understand the strengths and limitations of each system. You must ask the right questions. What are the span requirements? What is the required floor-to-floor height? What are the live loads? What is the construction schedule and budget? The answer to these questions will point you directly to the most appropriate slab type for your project. Now I want to hear from you. Which slab type have you found most effective on your projects, and what was the deciding factor? Let me know in the comments below. If this guide to slab systems has helped you, please give this video a like and subscribe for more content that builds your structural engineering knowledge.